Today we are diving into the world of classification in data mining, and more specifically, we'll look at some common errors that can occur during this process. Stick around and let's see how we can tackle these challenges. Before we delve into the errors, let's briefly discuss what classification is. Classification is a supervised learning technique used in data mining to predict categorical outcomes. In supervised learning, a model is trained using labeled data, which includes input-output pairs. It involves training a model using labeled data to recognize the patterns and make predictions on new, unseen data. The goal of the classification is to predict categorical outcomes or labels for new, unseen data based on the patterns learned from the label training data. During one of our previous videos, we saw the classification error for the iris dataset. Now we will take a look at what are the possible errors that take place in classification. If the predicted class label is different from the actual class label, sometimes we call the true class, then there is an error associated with that classification. Let's see what are some common problems that can occur during the classification process. Some common problems that can occur during this process are overfitting, underfitting, role of imbalanced data, insufficient data, as well as the inadequate feature selections. These things can cause issues and contribute to misclassification. Later, in another video, we will discuss the imbalanced data, insufficient data, and inadequate feature selections and their impact on classification. Right now, let's see what is misclassification error rate is. The error rate is the percentage of errors made over the entire data set. The error rate is also known as the misclassification rate, or simply called the error. As you can see on the numerator, we have the number of errors. On the denominator, we have the total number of samples. Okay, let's see what are the errors associated with learning and testing data. We call the error on the training data as the training error. The error on the test data is referred to as the test error. We can gain insights from the training error and testing error on how our models are doing. The classifier performs well on the new data, which is the data that not used for training, then it's a good generalization. Generalization refers to how well the model is performing on the new data, which is the data that we did not use during our training process of the model. If the model generalizes well, then it will perform well on the new data set that has the similar structure to the training data. Since the test error is an indication of how well the model generalizes to new data, the test error, also called as a generalization error. You will hear this term a lot from some textbooks or some articles written on the internet. We simply call the generalization error. Remember, the new data set should have the similar structure to the training data set. Another related concept to generalization is overfitting. If the model has a very low training error, but it has a high generalization error, or it has a high test error, then it is an indication of overfitting the model. Let's take a look at what it looks like when the model is overfitting. When the model becomes too complex and capture the noise of the training data, it may perform poorly on the new unseen data. To prevent overfitting, consider using generalization techniques or simplifying the model. Overfitting is an indication of poor generalization, as I said. Now, in a different video, we will discuss what techniques that we can use to simplify the model and avoid overfitting. We can use a validation data set to guide our process, our training process, to avoid overfitting. We will see what's a validation set in another video. On the left hand side, we see that the model is fitting to the structure of the data. On the right hand side of this image, we see that the model is fitting to the noise of the data. There is another concept with regard to the overfitting. It is called the underfitting. The opposite of overfitting, the underfitting, occurs when the model is too simplistic to capture the underlying pattern in the data. To address the underfitting, consider adding more features, using more complex models, or increasing the model's capacity. Underfitting takes place when the model has not captured the underlying structure of the data. Assessing the classification errors are crucial for improving. By identifying and addressing these common issues, you will be able to build more accurate and reliable classification models. Stay tuned for more tips and insights. So don't forget to like, share, and subscribe to our channel. Until next time, happy data mining.